Good day, this is the Professopher, drwillphd, PhD, and today is Thursday, February 2nd, 2023. It is 3:03 and 2 seconds, p.m. Eastern Standard Time, and today's research, fungal infections. So let's hop to it here. Molecular machines can treat fungal infections. Rice scientists show that light-activated nanoscale drills can kill pathogenic fungi. Date February 1st, 2023. Source: Rice University. That stubborn athlete's foot infection, an estimated 70% of people get at some point in their life, can become much easier to get rid of thanks to nanoscale drills activated by visible light. The research group's molecular machines are nanoscale compounds whose petal-like chain of atoms move in a single direction when exposed to visible light. And this causes a drilling motion that allows the machines to bore into the surface of cells, killing them. The researchers posed the question of whether they can also kill fungi, which had never been explored before. The study is the first to show that indeed these molecules can also be effective against fungi. As fungal infections pose a particular threat to patients with a weakened immune system, such as cancer patients and transplant recipients, the cost of treating bacterial infections in the United States alone is estimated at more than $7 billion per year. As COVID-19 has made matters worse, immunosuppressants were widely used early in the pandemic to reduce the risk of long-term organ damage caused by an overactive immune system in response to the virus, a tactic that allowed fungal infections to proliferate. In the aftermath of that first wave of the pandemic, doctors started seeing an increase in cases of mucormycosis, or black fungus, a normally rare fungal infection which causes a pneumonia-like illness as a result of the overuse of immunosuppressant drugs. They wanted to develop a way to combat fungal infections that does not tax a weakened immune system further, and they hoped that these molecular machines might be a way to do so. And this is an emergent phenomenon that they are just starting to understand. Antifungals are used in agriculture to combat damage to crops caused by fungal infestation. However, the research scientists say most of the antifungal drugs that are used in agriculture are also used in humans. Therefore, overuse of antifungals can lead to resistance, not just in fungi that cause plant illnesses, but also in other fungi, including those that can be harmful to humans. In contrast to most antifungals, development of resistance to visible light activated nanoscale drills, not detected, spinning at 2 to 3 million times per second. Their rotors cause fungal cells to disintegrate by disrupting their metabolism. There are only a few classes of antifungals in clinical use. These conventional antifungals typically employ one of a few different mechanisms of action, including inhibiting the synthesis of the fungal cell wall, targeting the fungal cell membrane, or inhibiting the production of ergosterol, which is an essential component for normal fungal cell membrane structure. The molecules differ from conventional antifungals in that they specifically target what they call the powerhouses of the cell, that is, the mitochondria. Mitochondria are responsible for producing adenosine triphosphate, or ATP, which drives cellular metabolism. By targeting the mitochondria, the molecules disrupt the cell's metabolism, resulting in an overall energy imbalance that leads to an uncontrolled flow of water and ions, such as calcium, into the cell, eventually causing the cells to explode. And this is the Professor of Microbiology, Bioinformatics, and Pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.